Assalamu alaikum. Today's lecture will be about the steady state errors. Remember when we spoke about the performance of any system? I mean the output of any system. We said that there is a period where the output varies significantly as soon as the system starts. Then it begins to settle. When the system settles, we call this period the steady state period. Now we are going to speak about the steady state errors and define what is the errors that we are speaking about. So we'll go to slide number 2. In slide 2, we have a typical feedback system. GP of S is the plant. H of S is the sensor and measurement of the feedback, which is transferred to the input and compared to the input, and the difference between the output after being multiplied by H of S and the input, which is R of S, we call it the actuating error signal EA of S, as shown in the figure in front of you. What is EA of S? From equation 1, EA of S is the input, R of S, minus what's coming from the output, which is C of S, H of S. Equation 2 describes the output, which is EA of S multiplied by the transfer function of the plant, which is GP of S. Substitute C of S from equation 2 into equation 1. You will get E of S, EA of S, equals R of S minus GP of S, H of S, times EA of S. Get E of S into one side and the rest to the other side. You will have EA of S, which is the actuating error signal, equals to the input, R of S, over 1 plus GP of S, H of S, as shown in equation 3. Note that EA of S, the actuating error signal, is equal to the input over what? 1 plus the loop. The loop in front of you, if you just go clockwise or anti-clockwise, whichever way you want. Normally we go clockwise. The loop is what? GP of S, H of S. Therefore, the actuating error signal is the input over 1 plus the loop. Okay, this is equation 3, and this is a very important equation which we're going to use all the time for the errors. Now in slide 3, we're going to get the output C of S. We have E of S equals R of S over 1 plus GP of S, H of S. We said C of S equals what? C of S equals this equation, EA of S, times GP of S. Therefore, the output, C of S, equals R of S times GP of S over 1 plus GP of S, H of S. So the transfer function, which is the output over the input, equals what? GP of S over 1 plus GP of S, H of S. In the second equation, which indicates the transfer function, you can see that instead of putting GP of S, H of S in the denominator, I put GH of S. What is GH of S? It is GP of S when you multiply it with H of S to Laplace transform functions. When you multiply them together, they give you another function, which is gh of s. It's just a notation. يعني ده notation فقط. Okay? So if you look at the transfer function and look at the figure, what is the transfer function? It is gp of s. What is gp of s in the numerator? It is the feed forward from the input to the output. If you go in a straight line from the input r of s to the output c of s in the figure of slide 3, you will find gp of s. So we call this the feed forward, feeding forward from the input to the output. And then the denominator of the transfer function is 1 plus the loop, the transfer functions in the loop that you have in front of you, which is the gp of s, h of s, which we called gh of s. These are two very important equations. Let's go to slide 4. In slide 4, we just want to see the system with unity feedback. If I want to represent the system or the figure, the above figure with the actuating error signal and the feedback h of s. If we want to have unity feedback, what should we do? We shall take the output, multiply it by h of s minus 1, which is shown in the second figure, and then take the output and multiply it by 1, c of s times 1, and add both. If you add h of s minus 1 plus 1, you will get h of s, which is the same figure, which is the first figure. Therefore, انت تقدر تفصل ال h of s على إنها two feedbacks. The first feedback, h of s minus 1, and then you add 1. Okay, as shown in the second figure. Why do we do this? Let's go to slide number 5. In slide 5, we shall magnify the part with the first feedback. Look at this figure that you have in slide 5. You have a feed forward, gp of s, and then feedback, h of s minus 1. So the transfer function of this part alone, this part which is magnified here, so that you can see it clearly, is what? It's the feed forward, which is gp of s, over 1 plus the loop. The loop is what? gp of s times h of s minus 1, which results in the small transfer function 1, which is equal to gp of s over 1 plus gp of s h of s minus gp of s. Okay? Let's go to figure 6. Now, when we look to the system as a whole, we have in the feed forward the transfer function 1, which we got in slide 5, and then we have unity feedback. So this is how we generate a unity feedback system. The error here, which is the difference between the input and the output, is called the error, not the actuating error signal. The actuating error signal means that you have in the feedback a component which is h of s or whatever. But when you have a unity feedback, the error is called just error. We don't say actuating error signal. Why? Because this error is equal to r of s minus c of s. This system is called a tracking system, because if the error equals 0, the e of s equals 0, this means that the output is exactly equal to the input. That means the output tracks the input. So this is a very well-known figure. When we say a unity feedback system, we may call it a tracking system. Okay? We shall call the transfer function 1, which we got from the previous slide. We shall call it G of S. Now, what is E of S? The same rule applies. It is the input, R of S, over 1 plus the loop. The loop is what here? It's G of S times 1, which is G of S. So if this system is stable, if we assume that this system is stable, therefore we can apply the final value theorem, which is E steady state, the final value of the error. يعني الerror هيسيتل على كام؟ E steady state equals what? It's the limit of the error when time goes to infinity, which is using the final value theorem. If the system is stable, it is the limit when s tends to 0, s في الفانكشن بتاعتك, which is E of S. So you have limit when s tends to 0 of s, R of S over 1 plus G of S. Here we call the error E steady state على طول. If we have feedback system, normal feedback system with H of S in the feedback, what will be the steady state actuating error? It will be the input, as we got it before. It's the input R of S over 1 plus GP of S H of S, normal. كويس. طيب, what will be the steady state actuating error signal? It will be limit when s tends to 0 of S, R of S, which is the input, over 1 plus the loop, and the loop then equals GP of S H of S. Okay? Note that E of S is not equal to E with the suffix A of S. Okay? This is called actuating error signal, and the other is called error signal. Okay? Let's go to slide number 7. Now we have derived the error of any closed loop system to be the input, R of S, over the loop. This equation you have in front of you is if I have a unity feedback. Therefore, the denominator is 1 plus G of S for a unity feedback system. If we do not have a unity feedback system, this equation will be changed to E A of S equals R of S over 1 plus GP of S H of S. Okay? Now, in general, what does the error signal depend upon? From the numerator, it depends upon the input. From the denominator, it depends upon the system. The system itself, the parameters of the system, which is G of S. Therefore, the errors depend upon the input, which is on your right, the green part, and the type of the system. And we shall explain what's the type of the system in the next slide. Okay? The input, we shall consider several inputs that may enter any system, like the step, the ramp, the parabola, and so on. The types, we shall consider type 0, 1, and 2. And we shall explain what's the type of the system in the next slide. We shall consider the errors, the steady state errors. What will happen? The target of this lecture is to find out what are the steady state errors for the different types of systems with different inputs to the system. Let's go to slide number 8. We shall explain here the type of a system. If let's say we have a unity feedback system and we have G of S. What is G of S? G of S is a function in the S domain. In general, what is a function? It's in the S domain. It is numerator over denominator. So it's a polynomial over polynomial in the S domain. Now the polynomial in the numerator, we can say it is equal to, for example, if we had S squared plus AS plus B. So we can factorize the numerator into S plus x1 مثلا times x plus x2. Yes. But what if we want to put it in the form of something multiplied by s plus 1? So you take the x1 common factor and the x2 common factor, and you have 1 over x1 s plus 1 times 1 over x2 s plus 1, and then you multiply by x1 times x2. Okay? So the numerator can always take the form of TAS plus 1, TBS plus 1, and so on. What's this constant at the beginning? K. What is this K? It is the gathering of all the constants that you took as common factor. This is the numerator, okay? We shall do the same thing with the denominator. The denominator is a polynomial. The polynomial has certain poles. So we're going to gather all the poles and include it in K. And then we have T1s plus 1, T2s plus 1, and so on. Now, what if we have 0 poles? Remember, what is a pole of a system? What is a pole of a function? It is the value of the function when it equals to infinity. يعني الدينومينيتور يساوي 0. When I say 0 pole, I mean s equals 0. So here we may have 0 poles. I may have 1 0 pole, therefore I have s to the power of 1 in the denominator. I might have 2 0 poles in the g of s function, therefore I have s to the power of 2, and so on. So here, in general, s to the power of n indicates the number of 0 poles in g of s. Remember, g of s is the feed-forward part of your system, okay, for a unity feedback system. يبقى الشكل اللي هحط فيه g of s هو ايه؟ هو الشكل اللي قدامك ده. شوية constants هلمها عشان اخلي السيستم بتاعي شكلها ستاندرد. يعني ايه؟ يعني هحطها حاجة في s plus 1، حاجة في s plus 1 في النيوميريتور، وحاجة في s plus 1 في حاجة في s plus 1 في الدينومينيتور. وفي نفس الوقت لو كان عندي 0 بول يبقى هعمل ايه؟ هحط s to the power of n. لو كان عندي n بواحد يبقى this is 1 0 بول، او بنقول عليها type 1. لو كان n ب2 يبقى type 2. لو كان n ب0 يعني s to the power of 0، يعني ما عنديش الاس بتاعت الدينومينيتور دي، مش موجودة خالص، يبقى في الحالة دي بقول عليها type 0 system. This is the meaning of the type of the system. The type of the system is indicated by the power of s standalone, which we indicated by the capital letter N. Okay, what are we going to do now? Let's go to slide 9. In slide 9, we are going to study the response of the system at steady state for the different inputs with respect to the different types of the system. So here we are, what are we seeking? The steady state error. Under what kind of inputs? Step input, ramp input, and parabolic input. And what type of systems? Type 0, type 1, and type 2. We shall try to fill this table in front of you. First, we're going to find what is the steady state error if we have a step input, as we shall see in the next slide. Here, if we have a step input, what is the equation of a step input? It is M, it has an input of step, M, magnitude M, and we indicate the step input by U of t, or U of t. Okay? M, capital M, is the magnitude. يعني ممكن يبقى عندي مثلا DC voltage قيمته 5 فولت مثلا. اوكي؟ ده الانبوت اللي داخل على السيستم بتاعي. يبقى ده عبارة عن ماجنتيود 5 مضروب في ستيب يونيتي ستيب انبوت اللي هو بنعمل لها انديكيشن بيو اوف تي. اوكي؟ يبقى R of t equals mu of t. What is the Laplace transform of R of t? It is m over s using the Laplace transform. Apply the steady state rule that we got earlier. E steady state equals what? It's the limit when s tends to 0 of s times E of s. E of s is the input R of s over 1 plus اللوب. اللوب هنا عندك G of s. Substitute R of s by m over s. You see, in equation 1, the s in the numerator will be cancelled with the s in the denominator of the numerator of the fraction. اللي هما الاثنين s اللي معمولين بالأحمر هيروحوا مع بعض. يبقى أنا عندي هنا إيه؟ هيتفضل لي إيه في الإيكويشن دي؟ m على 1 زائد g of s. طب الليمت لما تدخل على m، يعني limit when s tends to 0 of m. What is the limit of s tends to 0 of m? It's m. And what is the limit when s tends to 0 of 1? It's 1. So الليمت هيخش على ايه في الايكويشن اللي قدامك دي؟ هيخش على g of s only. يبقى I will indicate limit when s tends to 0 of g of s by a value or variable which I'm going to call kp, as shown in equation 1. So the steady state error, if you have a step input of magnitude m, is equal to m over 1 plus kp, where kp equals the limit when s tends to 0 of the loop اللي هي g of s. And we call the variable kp the static position error coefficient. يعني الارر خد فورمه كده، خد شكل اللي هو m على 1 زائد kp. where a what is kp ده؟ ايه kp ده؟ هو الليمت لما s tends to 0 بتاع اللوب بتاعتك اللي هي في حالة اليونيتي فيدباك هي g of s. Okay, let's go to the second slide. هنا we're going to get a type 0 system. What is a type 0 system? It is a system where the capital N is equal to 0. فيبقى الفانكشن بتاعتك اللي هي g of s اللي هي قدامك في الايكويشن الاولانيه دي هتبقى بتساوي k في tas plus 1 tbs plus 1. ده في النيوميريتور. في الدينومينيتور هيبقى t1s plus 1 t2s plus 1 and so on. مفيش عندي s to the power of n لان ال s to the power of n بقت s to the power of 0 اللي هي 1. طيب لما تاخد الليمت بتاع الايكويشن دي وتحط s بتساوي 0 هيدي لك الكي بي بتساوي k. يبقى ساعتها الستيدي ستيت ايرور هيساوي ايه؟ ما هو m على 1 زائد كي بي والكي بي بتساوي k، يبقى m على 1 زائد k. اوكي. For a type 1 بقى او تايب 2 او تايب 3 whatever التايب، يعني خلي الان بتاعتك من 1 لغايه whatever 5 6 تايب 2 تايب 3 4 5 whatever الكابيتال ان بتاعتك. حطها بقى في الايكويشن اللي تحت دي وحط الاس بتساوي 0. هتلاقي ان انت عندك الكي بي بتساوي كي على اس to the power of n، والاس بتساوي 0 في الاخر، يعني كي على 0 يعني انفينيتي. يبقى الستيدي ستيت ايرور بتاعك بيساوي 0. which means ايه؟ يعني ايه معنى الكلام ده؟ معنى الكلام ده ان لو كان عندك الانبوت اللي داخل is a step input with magnitude m، الايرور بتاعك هيساوي 0 لو السيستم كان تايب 1 او تايب 2 او تايب 3. طب لو كان تايب 0 لا، يبقى ساعتها عندك ايرور بيساوي كام؟ هو m على 1 زائد k. هنكتب الكلام ده في التيبل في السلايد اللي بعد كده. نتنقل على السلايد اللي جاي. هنا التيبل where we have discussed the step input, the steady state error due to a step input as shown في الايكويشن اللي عندك بالاحمر هنا بتساوي ايه؟ لما يبقى عندي step input هتساوي m على 1 زائد كي بي، ده الفورمه بتاعتك. طب الانبوت ستيب يعني واخد شكل ايه؟ ان الار اوف تي بتساوي ام يو اوف تي. طب لو عندي تايب 0 what is the steady state error؟ it's equal to m على 1 زائد k. طب if I have type 1 the steady state error will equal to 0. if I have type 2 the steady state error equals 0. 3 4 5 كله بصفار بعد كده في التيبل اللي قدامك. اوكي، let's see what will happen if we have a ramp input. Go to the next slide. Here if we have a ramp input, which means that r of t equals a certain slope m times t u of t. Why do we put u of t here? Just to indicate that we do not have an input with negative time. يعني ايه؟ يعني الانبوت بتاعي دايما بيبتدي من t بتساوي 0. ما عنديش في النيجاتيف تايم اي input. اوكي، مش كده احنا حاطين هنا اليو of t. You can skip it if you just indicate that t is greater than, small t is greater than or equal to 0, which implies that you are starting the analysis when time equals 0. No negative times. يبقى الانبوت بتاعك mtu of t. طب نجيب اللابلاس ترانسفورم. What is the Laplace transform of mt? It's m over s squared. عوض بقى في الايكويشن بتاعت الايرور steady state error. شيل الار اوف اس في ايكويشن 1، شيل الار اوف اس وحط بدلها m over s squared. واحد من السكويرد الاس ده هيروح مع الاس اللي هي بتاعت اللي جنب الليمت. هيتفضل عندك ايه؟ m على s plus s g of s، لان الاس اللي هي اللي بتاعت اللابلاس ترانسفورم m over s squared اللي فاضله هتنزل في الدينومينيتور. خد بقى الليمت لما s tends to 0. لما الليمت لما s tends to 0 of m is m. limit لما s tends to 0 of s equals 0. limit of s tends to 0 يعني. طيب what is the limit when s tends to 0 of s g of s؟ معرفش. it depends على ال g of s شكلها ايه. يبقى في الحالة دي هسميها ايه؟ kv. هسمي الليمت لما s tends to 0 of s g of s هسميها kv، اللي هي بنسميها it's a constant أو coefficient which we call static velocity error coefficient. اوكي، يبقى انا الايرور بتاعي لو دخل عليا رامب هياخد فورمه اسمها m على kv. what is kv؟ هي الليمت لما s tends to 0 of s g of s. اوكي، نروح على اللي بعده. the input is ramp. remember the input is ramp. we shall consider what will happen if we have a type 0 and the input is ramp. kv هتساوي ايه؟ نطبق القانون بتاعها. هي الليمت لما s tends to 0 of s في الجي اوف اس. الجي اوف اس لما السيستم يبقى التايب بتاعه 0 هتاخد الشكل اللي قدامك في الايكويشن اللي فوق دي، اللي هي من غير s to the power of capital N، لان ال N هنا عندك بصفر. طب خد الليمت لما s tends to 0 هتساوي صفر. الايكويشن اللي قدامك دي هتساوي صفر. اوكي، طب اذا كانت الستيدي ستيت ايرور ام على كي في والكي في بتساوي صفر، يبقى الستيدي ستيت ايرور بتاعك انفينيتي. يعني لو كان السيستم داخل عليه الانبوت بتاعه رامب وهو تايب 0 هيديلك ايرور بانفينيتي. طب لو كان تايب 1 زي ما واضح عندي في ايكويشن اللي هي الاخرانيه في السلايد دي، لو كان تايب 1 يبقى عندي في الدينومينيتور s to the power of 1 هتروح مع الاس اللي جنب الليميت، يبقى في الحاله دي لما تاخد s بتساوي صفر هتدي لك الايكويشن كي في هتدي لك كي. ساعتها الستيدي ستيت ايرور هيساوي m على k. طب نروح للي بعدها، السلايد اللي بعدها. What will happen if the system is a type 2 أو 3 أو 4، يعني التايب 2 فما فوق؟ هيبقى هحط هنا في الايكويشن اللي قدامك دي s to the power of capital N where N can be 2 3 4 whatever. لما اخد الليميت لما s tends to 0 بتاع الايكويشن دي هلاقيها بتساوي انفينيتي، يبقى الستيدي ستيت ايرور بتاعك بيساوي صفر لان هو m على كي في والكي في بتساوي انفينيتي، يبقى ده بيساوي صفر ستيدي ستيت ايرور. هحط الكلام ده في التيبل في السلايد اللي بعد كده. نروح على السلايد اللي بعد. شايفين هنا في التيبل when we have a ramp input اللي هو مكتوب لك بالاحمر اللي هو الكولوم اللي بالاحمر. If I have a ramp input the steady state error will take the form m over kv. The input is a ramp which is equal to mtu of t. What will be the steady state error if you have a type 0? It will be infinity. If you have type 1 it will be m over k. If you have type 2 it will be صفر. ده الكلام ده اللي احنا جبناه في السلايدز اللي قبل كده. اوكي، فهنا I have completed the second column of this table. Let's go to the next slide and study the parabolic input. طبعا خلاص الفورمة وضحت قدامنا. لو انا عندي بارابولا كويس هقول ايه؟ الايرور بتاعي هيساوي ايه؟ m على k a. الكي a ده هيساوي ايه؟ ليميت لما s tends to 0 s سكويرد في g of s، وهسمي الكي a ده static acceleration error coefficient. اوكي، زي ما عملنا قبل كده بالظبط، يعني كل اللي احنا اللي فات بنعيد نفس الحكايه، بس مره كنا بنقول ستيب انبوت، مره بنقول رامب انبوت، دلوقتي بنتكلم على بارابولا. اوكي، نروح بقى نكمل التيبل بتاعنا في السلايد اللي بعد كده. This is a summary of all what we said in this lecture. التيبل بتوضح ال steady state errors for the different inputs and the different types. Okay.